Okay, this is number 1 on your chapter review. Locate the absolute extrema on the interval. We know that absolute extrema means absolute maxes or mins, and we find absolute maxes or mins by finding the derivative, setting it equal to 0. So the derivative of 2x cubed is going to be 6x squared minus the derivative of this would be 24. So now I'm going to set the derivative equal to 0. I can factor out a 6, and I have x squared minus 4. So set each factor equal to 0. So 0 equals 6. Well, that can never happen, so I don't have to worry about that. 0 equals x squared minus 4. So 4 equals x squared. So that means x equals plus or minus 2. Now here's the deal. So I have critical points at plus and minus 2, but I only care about this interval. The interval starts at 0, ends at 4. So I don't have to worry about this negative 2. Now when we want to find the absolute extrema, this is that very first section that we did, where now we're going to check our critical points. I'm going to check f of 2, and when I say that, I'm plugging it into my original equation. And then I need to check my endpoints. Because we know if it's a continuous function and on a closed interval, then I have to have a max and a min on that function. Okay, so when I plug 2 in, 2 times 2 cubed minus 24 times 2. And then right now I'm just plugging my numbers in. 2 times 0 cubed minus 24 times 0. I'm plugging 4 in. Okay, so this one I'm going to get 0. F of 2, when I work this out, I'm going to get negative 32. And when I work this out, I get a positive 32. So I have a max. I'll just label it like this. I'm sorry, it's a min. And a max. So I have a max when x equals 4, a min when x equals 2. Okay. Example 2, or number 2. Find the 2x intercepts of f of x equals x squared minus 3x minus 4, and then show that f prime of c equals 0 at some point between those two x intercepts. Well, this first part, find the 2x intercepts, that's just an algebra question. Okay, we're going to set that equal to 0 and solve. I can solve this lots of ways. I can graph it, see where it crosses the x-axis. I can use the quadratic formula, or I can just factor this. This factors pretty easily. X minus 4, x plus 1. And in fact, this problem would probably be on the non-calculator part. So each factor equal to 0. So I know x is 4 and x is negative 1. So it crosses the x-axis at those 2 points. So that was my first part. My second part says find f prime of c and set it equal to 0. So I'm going to find the derivative of this. Derivative of f of x is 2x minus 3. Okay, it tells me to set this equal to 0 and solve. So that's 3 equals 2x. So x is 3/2. So this is my value c. And what they're saying is this value c needs to fall between my two intercepts. Okay, that's what it says. Show that f prime of c, my c is 3/2, falls between the two x-intercepts. So 1.5 goes between negative 1 and 4, so I'm good. And that's my answer. Okay, number 3. Number 3 is just like number 1. Locate the absolute extreme again. A closed interval from 0 to 5. I would, before I found the derivative of this, rewrite this as 2x over 3 plus 5 over 3. That's going to be the easiest way to find the derivative. I could use the quotient rule, but it's going to be a lot more work. So the derivative of this, derivative of 2/3 x is just 2/3. Derivative of 5/3 is 0. So normally I would take my derivative and set it equal to 0, but that doesn't make sense. It's never going to happen. So I'm not going to have any critical points, but I need to figure out now my endpoints. Okay, so I need to check my endpoints, but I had no critical points to check. So now I'm plugging 0 into this. So 2 times 0 plus 5 over 3, that's going to be 5/3. Now I'm plugging 5 in. So that's what, 15 over 3 or 5. So this has to be my max. This has to be my min. Okay, number 4. The derivative of a function that is decreasing will always be blank. Well, we know that if a function is decreasing, the derivative is negative. Then it says the derivative of a function that is increasing will always be, well, we should know that when a function is increasing, the derivative is positive. Okay. Number 5. For the given function, I'm supposed to find the critical numbers, find the open intervals in which it's increasing, decreasing, and do the first derivative test to identify the relative extrema, or maxes and mins. Right, so first we're going to find the critical numbers. We find critical numbers by finding the derivative, setting it equal to 0, or where the derivative is undefined. So f prime of x, the derivative of x is 1, plus the derivative of 2 sine x is 2 cosine x. I need to set this equal to 0, and now I'm going to solve this. Okay, subtract 1 from both sides. So negative 1 equals 2 cosine x. Now I'm going to divide by 2. So I have negative 1/2 equals cosine x. So I need to figure out at what angle is cosine negative 1/2. Okay, so on this test, I'm going to let you use your unit circle, but we need to start learning how to find those angles without our unit circle. Cosine is negative in this quadrant, second quadrant, all students take, and this quadrant. We know that cosine is adjacent over hypotenuse. So my hypotenuse is 2. My adjacent side is negative 1. So when I do the Pythagorean theorem, I have a 30-60 triangle. So 30 degrees is always opposite my 1. So if this is 30, that means this right here is 60 degrees. So the angle that I want starts here and goes all the way over. So it'd be 180 minus 60. So that's going to be 120, but 120 in radians is 2 pi over 3. And then my other angle all the way around is 180 plus 60, and that's going to be 4 pi over 3. Okay, so those are my critical numbers, 2 pi over 3 and 4 pi over 3. Then it says find the open intervals where it's increasing and decreasing. All right, so this is where I'm going to use my sign chart. 2 pi over 3, 4 pi over 3. Now, I should have said in this problem, okay, that we're only going from 0 to 2 pi. Otherwise, we could keep going on and on forever, all right? So I'm going to go 0 to 2 pi. So I'm going to choose a number between 0 and 2 pi over 3, like pi over 3, and I'm plugging it into my derivative. Okay, so when I plug that into my derivative, I'm going to get a positive answer. Then I have to choose a number between 2 pi over 3 and 4 over pi over 3, like pi. Plug it in, and I'm going to get negative. A number above 4 pi over 3, when I plug it into the derivative, I'm going to get a positive. So Find the open intervals in which it's increasing and decreasing. So here's part B. F of x is increasing from 0 to 2 pi over 3 and from 4 pi over 3 to 2 pi because f prime of x is greater than 0 on the interval. F of x is decreasing from 2 pi over 3 to 4 pi over 3 because f prime of x is less than 0 or negative on the interval. And then part C says identify all relative extrema. So that means find our maxes and mins. Okay, f of x has a max, and I'm looking where the derivative went from positive to negative. So it went from positive to negative when x is 2 pi over 3. Because my derivative went from positive to negative. And then f of x has a min at x equals 4 pi over 3 because f prime of x went from negative to positive. Okay, so I'm going to stop there. Those are problems 1 through 5. 6 through 10 will be on the next video.